Hi, do you want to know more about the mysteries of math? Come, let's meet our friends. Say hi, guys.
Hi! Oh, hey! Have you ever observed a dripping faucet and wonder why sometimes its rhythm is steady, sometimes it's unstable? So, what's going on?
Uy! In Chapter 9 of Nature's Numbers by Ian Stewart, we dive into the fascinating world of chaos, patterns, and how nature follows mathematical laws.
Let's explore how even something as random as a drop of water or as beautiful as a flower is shaped by math.
The chapter begins with the dripping tap. The first drops fall at regular interval, but eventually the rhythm shifts. It becomes erratic and hard to predict.
This randomness is an example of chaos theory. Even simple systems can behave unpredictably when their starting positions change even just a little.
In short, mathematics reveals that chaos isn't just a disorder, it has its own hidden rules.
On the other side of nature, we find beauty and math. Take a flower. Its seeds and petals form spirals that form the Fibonacci sequence.
Now, this arrangement isn't just pretty, it's efficient. It allows plants to pack the most seeds in the small pockets. And as Stewart has said, what looks like a flower's natural design is actually a mathematical solution to an efficiency problem.
This pattern is called phytotaxis. From pine cones to petals, nature speaks in numbers.
Whether it's chaos or order, both show us one thing. Math is everywhere.
From drops to daisies, Ian Stewart teaches us that nature doesn't just happen. It follows strict patterns that we can understand.
In chapter 9 in Nature's Numbers, opens our eyes to the hidden math of nature.
So the next time you see a drop fall,
Uy! Or a flower bloom,
Remember that there's math behind the magic. That's it for today's guys. Bye!